Welcome, everybody. We're SISBNs from Singapore International School of Bangkok and also Vape Detectives. Today, I'm excited to present to you our vape detection wristband, an innovative device that combines AI and sensor technologies to address the growing concern of vaping. With vaping on the rise, we aim to create a solution that helps people monitor and reduce their vape usage in real time through data collection and personalized insights. Now, let's dive into how this device works and the role AI plays in the solution. This will be our table of contents, starting by introduction, problem statement, our innovative solution, and acknowledging the challenges. Quitting vaping is often a challenging journey due to cravings driven by the variety of flavors and brands available. In Thailand, although vaping is illegal, the law is not strictly enforced. In response, we, the SISBNs, have created and designed a vape detection system that allow users to quit vaping, minimizing the health effects towards others and themselves, empowering users to take control of their behavior and ultimately quit vaping for good. Vaping has become a significant concern, mainly in school environments. 61% of teen vapers admit to being addicted, despite awareness of the risk and a strong desire to quit. Many teen vapers are unsuccessful without proper intervention strategies. The statistics highlights the growing need for technologies like vape detection system and interventions that not only prevent vaping in school, but also support the individuals in their journey to quit for our generation, the future generation, and for a better tomorrow.
This is our innovative solution, the wristband that detects vaping before you actually vape. First of all, there's Raspberry Pi, which is a microprocessor and the system's brains. Then there's the accelerometer and gyroscope, which are responsible for the unique hand movements and rotations associated with vaping. Then there's the temperature sensors, which detect changes in the temperature when the atomizers of the vape is being used. Then there's the gas sensors, which identify the vape residue in the air, which ensures accurate detection and collects failed detection attempts. Then there's the battery, which is a lithium polymer battery that ensures that the device stays on. And lastly, there's the vibration motors, which acts as a feedback mechanism and helps us stop vaping when it's detected. Our wristband algorithm uses simple classification models of logistic regression to predict whether the user is vaping based on the data fed. We separate the data into two sets. The first set is the training set. The set has data from the sensors and the Boolean values of whether the data means vaping or not. Then the second set is the test set, where the algorithm is given the data and is then used to predict the Boolean value. The values are then compared to an answer key. This process helps us train and fine tune the model. Then, after getting some preliminary results, we plan to move on to the more advanced and complex models to get more accurate results, such as random forest, gradient boosting machines, and even neural networks to improve accuracy. We also plan to integrate a data collection app into our wristband, whereby our wristband transmits real time data to a mobile app, which stores and organizes this data for analysis, where over time we can gather enough data to train our machine learning models and improve the device's performance. Then we also have adaptive AI, where the AI tracks the user's vaping habits and adapt to their personal patterns, where over time it learns the specific behaviors of the users, which allows us to generate more personalized insights and recommendations. Challenges in the future. First of all, there's portability, which is an important aspect when it comes to achieving real life applications. The wristband must be lightweight, small, and must not hinder any movements. So, in the future, we will attempt to develop it into a smaller and faster industrialized PCB board. Also, hand movements are unique and really hard to differentiate. So we need to collect massive amounts of data, which is really hard in order for it to achieve a consistent and accurate result. Which brings us to the third point, where collecting data will be really difficult and meticulous, where the goal of collecting massive amounts of data is really time consuming. Lastly, the apps can still be improved and a lot of features are still possible. For example, we plan to implement generative AI to help reduce vaping, which will suggest coping mechanisms for individuals. The goal of our project is not just detection, but to actively encourage healthier habits.